Hello everyone. This session I will cover the scikit-learn code for the agglomerative clustering techniques. And also we will recap the previous session here in short, right? So in the previous session already we have discussed the different types of clustering, right? So mainly two types of clustering, hierarchical clustering and non-hierarchical clustering, right? And in the agglomerative is the example of the hierarchical clustering, right? Where we use the tree data structure dendrogram, right, to show the process of agglomerative clustering, right? And methods for computing distances between these clusters are, we also use the different linkage criteria, right, which is also called as the linkage strategies to aggregate the different cluster. So also we discuss what single link, complete link, average link, and centroid based link criteria for merging the clusters here, right? So there are two types of agglomerative clustering. Again, in the hierarchical clustering, there are two types. That is agglomerative clustering, which is bottom-up approach, which is part of our syllabus, and divisive clustering method, which is top-down, which is similar to the agglomerative. Only the process is reverse here. That only we are not going to cover here, right? So here first we will discuss the data formats for agglomerative clustering, right, which is bottom-up approach. So let us consider the following data set. Here again, my x variable represents the data set here, right? And which is set of what? All the different samples, x1, x2, xn, n samples, which is made up of m features, right? So here my data set is a numerical data set, right? And here my xi belongs to r raised to m, right? My data set is a numerical data set, and my xi is nothing but the one ith sample which will belongs to r raised to m. Here m represent the number of features and n represent the number of samples in my data set, which we have discussed in the previous session. Also, the most common metrics for similarity measures are also supported by the scikit-learn code are Euclidean distance, that you know, which is L2 norm. So here is the formula for the Euclidean distance that already you know. Then we can use also we can use Manhattan distance metric for calculating the distance between the two objects here, right? Here is the formula, right? Where we use the absolute value between the difference between the two objects, right? Then also we can use the cosine distance formula, right? And also we use here the different linkage strategies, right? Complete linkage, where we consider the maximum distance, right, between the clusters, right? And here is the formula given. The distance between the two objects is nothing but what? The max of distances of all the objects between the two objects, right? And here in the single linkage, which is same as the complete linkage, only the distance between the two clusters, we consider the minimum distance, the pair of the two objects, right? So minimum distance with the cluster here, right? So the formula will be same as this, only here instead of max, here should be min here in the single linkage. Then we also discuss the average linkage, where we consider the average distance between the pair of clusters, right? So here is the formula for calculating the average distance between the pair of the cluster. Here also we have covered in the previous session. And one more is there Wards linkage. In this method, all the clusters are considered, and the algorithm computes here the sum of square distances within the clusters and merges them to minimize it. So this is the formula for calculating here the sum of square distances within the clusters, right? So all these are the different merging criteria we require in the agglomerative clustering. And one more parameter we discussed, that is dendrogram, which is graphical method to better understand the agglomeration process. Shows in a static way how the aggregation are performed starting from the bottom, where all the samples are separated till the top, that is where linkage is complete here, right? Also we have covered this. Now we'll see the scikit-learn code for the agglomerative clustering. If you want to display here dendrogram, right, also there is an inbuilt package, and methods are available to display the dendrogram, right? But here scikit-learn does not support the dendrogram package, right? So for that you need to install here SciPy, right? So SciPy is a mandatory requirement to plot the dendrogram here. You can remember, students. So here is the code for visualizing the dendrogram. So to create and visualize the dendrogram, here is the scikit-learn code from SciPy, right? From scipy.cluster.hierarchy import dendrogram. So you remember this scipy.cluster.hierarchy import dendrogram, and just you can mention here xd equal to dendrogram in bracket your data set. X is my data set. So this method, right, if you plot here this xd, you will find this dendrogram, right? So this is the visualization of your dendrogram using this SciPy package here, dendrogram package. I hope student you are clear with this. You can try also in the Jupyter notebook, right? Then we will discuss here the scikit-learn code for the different linkage agglomerative clustering techniques, right? So let us create first data set using scikit-learn code. So here we have created in this slide the dummy data set of 8 different centers, right? So here centers are nothing but my clusters. So here number of samples I want in the data set is 3000 that we have initialized with the variable. Then make blob method we have used here to create this data set, dummy data set. So first parameter we have passed is the number of samples, which is 3000. Number of features in the data set I want 2, and number of cluster I want 8 here, right? So this is the graphical representation of my data set, right? I hope student you are clear with this. Then next is what the agglomerative clustering for the different linkage strategy, right? So agglomerative clustering with different linkage can be used here, always keeping the Euclidean distance and compare the result. Here we by default the scikit-learn code considers the Euclidean distance, right? When they apply the different linkage strategy, right? So this is the code for now the complete linkage. So agglomerative clustering uses the method fit_predict. You can note down student here. Agglomerative clustering uses the fit_predict method to train the model and transform the original data set. Right? To convert the data set into set of cluster, it uses the fit_predict method like your other techniques. Right? So here is the scikit-learn code for this method. So from sklearn dot cluster, you can remember here sklearn dot cluster is my package where we need to import this method agglomerative clustering. A is capital and C is capital here. Then here create the object of agglomerative clustering. So AC equal to agglomerative clustering. And what parameters we are passing to this method? Number of cluster. So n_cluster equal to 8, right? And linkage strategy you need to mention here. So linkage is the inbuilt keyword. Linkage equal to complete. In the single code, you can mention your strategy name, which is here complete, right? So 2 parameters we are passing, number of cluster and the linkage strategy, right? So after creating the object of the agglomerative clustering, you can fit the model. So here for fitting the model, we use fit_predict function. So y equal to ac dot fit_predict in bracket, my data set is X, right? So my data set is X, that dummy set data set we created in the previous slide. I hope you are clear with this. So the output of this agglomerative clustering with the complete linkage strategy will be this. So this is the plot of the result, right? Then we'll see the code for the average linkage strategy. So again, my method is same as previous. Only my linkage strategy will change here. So here create the object of the agglomerative clustering with the number of clusters, again 8 here, and my linkage strategy is now here average. So you can remember here only we need to change the linkage strategy. So now it is average. Again, after creating the object of this agglomerative clustering with this new average linkage strategy, you need to fit the model. So y equal to ac dot fit_predict. Now again we are passing the X data set. So this is the result of the average linkage strategy. And if you observe here again, the number of clusters are 8, right? With the different color and different shapes, right? So I hope student you are clear with this. Then next here is the code for the Warts linkage method. So by default, actually this scikit-learn takes the Wart linkage strategy to merge the two clusters, right? So that can be used with the Euclidean metric only. So S equal to, here we are creating the again object of the agglomerative clustering with the number of clusters 8, and my linkage strategy is now Wart linkage, which is by default. So it is optional, and that's why it is not mentioned here. So S equal to agglomerative clustering n underscore cluster 8. Now the second parameter is missing because by default it will take Warts linkage, then feed the model for your data set, right? So with this model, if you display the graph, then you will get this graph of 8 cluster, right? Using what? Warts linkage strategy. I hope student you are clear with this. Thank you.